This is a continuation of part C of problem 2. And so now we have a Z total, right, is equal to Z of R plus Z of L plus Z of C, right? So what I'm asking is, first we learn the R and L, and I apologize for the blurriness. I'm trying to get this dot cam to work. Okay. And then we have what? 100, right? Or whatever that number is, R plus J omega L, and a minus J over omega C, right? So this is a problem. This is kind of the problem we're looking at. And how does this work? Now the question is, what I'm asking is, how does the capacitor here, regulate that inductor, right? So what happens, and we're not going to do the frequency on this because we covered frequency earlier, but what's really going on in this case, right? So as we know that the reality is this is, minus J over 2 pi F C, right? Something like that, okay? So now the question is, how do we, this is an F, how do we, how do we control this, right? So if we have a triangle as such, right, what we're trying to do, here's my triangle. Sorry, let me draw the triangle. So I have my real component, I have my imaginary component, and then I have the angle, okay? And let's just say this is 100 or whatever numbers. And this is plus J omega L, okay? Now, obviously a minus J would have to reduce this one right here. I have to be able to reduce this angle. So we studied this earlier with the power factor and what happens, okay? So let's kind of combine these two concepts together. If I have an increasing, I have a C, and the problem is I have an existing inductor. Now I have an existing inductor, and I'm going to add a capacitor. What happens to my entire system? That's what I'm asking you. So this is going to be J omega L minus J of omega C, okay? Or ZL plus ZC, okay? And then I'm going to ask you, obviously, the power factor. Okay, I'm going to ask you the power factor, and I'm going to ask you power factor, and I'm going to ask you, obviously, the efficiency. Okay, so if I add the following capacitor, eraser here, and I increase the capacitance, what's really happening to this system? The previous problem, if you analyze the previous problem, I'm asking you what happened when I increase the capacitor, what happens to Z of C by itself? But now I'm asking you, is the entire system is affected because I already have an existing impedance. So if I were to, so if my capacitor goes up, that means what? That means my lower denominator, right? My denominator is increasing. If my denominator increases, what happens to my numerator? It decreases, right? So my whole number here is decreasing. So if this number is large, this number here is going to be small. What is large minus small? It's still large. Okay? It's still large. So if this is large, if this is large, then my angle is what? Large. It's very large. If my angle is large, then what happens here? If my angle is large, my efficiency is low. My power factor is low. My efficiency is low. If I were to decrease the capacitance, but I can't make it 0, obviously, I decrease it, I still have what? Large, which is my J omega L, minus what? This is the one I'm changing, okay? So right here, this is what's in question, okay? So I'm subtracting what? So if I decrease my capacitance, as my capacitance decreases, what happens to this big number here? It increases. So my large becomes large. Is what? What is large minus large? Very small. So now this whole effect here is very small. So what happens? This now goes down, right? What happens when this angle goes down? If the angle is low, my angle is low, my power factor is high, my efficiency is high. Okay, that is the derivation in two parts for number C. Okay, so understand part A about the inductor. Then part B is about the A and B is about the inductor. Part C, and part C is in two parts. The first part is going to be the capacitor by itself and understanding the capacitor by itself. But when you understand the capacitor by itself, what happens when I add the system, and how it regulates the system, right? How I pull that down, okay? And then create more efficiency. My goal is to really increase that efficiency, okay?